Hello everyone. Welcome to the solution of LeetCode problem 2471 named minimum number of operation to sort a binary tree by level. Now here in this problem, you are given a root of a binary tree with unique values. In one operations, you can choose any two nodes at the same level and swap their values. And you have to return the minimum number of operations needed to make the values at each level sorted in a strictly increasing order. Now, the level of a node is the number of edges among the path between it and the root node. So here, let's consider this first example. The root node 1 has two children, 4 and 3. 4 has two children, 7 and 6. 3 has two children, 8 and 5. 8 has one children, 9. And 5 has one children, 10. Now here, in the second level, 4 appear before 3. That means it is not sorted. So we have to swap 3 and 4. So it is one operation. In the third level, 7, 6, 8, and 5. The order is not sorted. So we can swap 7 and 5. So 5 will appear here, 7 will appear here. After that, we can swap 8 and 7. So here, by using 2 swap, it will become 5, 6, 7, and 8. And in the fourth level, the values are 9 and 10, so which is already sorted. So here, it can be proven that 3 is the minimum number of operation needed. So far, so good. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, we have taken the same example. So here, the first question is, how can we solve this problem? The first intuition is, as in the problem statement, we have told that this is the level by level problem. That means we have to sort the value in each level. So we can simply use the BFS algorithm. So why BFS? Basically, BFS is the level by level search technique in a graph or tree. So here the intuition is very simple. For each level, we will apply BFS and we will store the value presented at each level and we will try to perform the swapping operation. So I hope you understand why we use the BFS. Now the second question is how basically the swapping works. So here, this is the level 0, this is the level 1, this is the level 2, and this is the level 3. Okay, now suppose let's consider the swap operation into this level. So here at first, if we swap the element 5 and 7, the order will become 5, 6, 8, and 7. After that, if we swap the element 8 and 7, the order will become 5, 6, 7, 8. That means we have to use 2 swapping here. So now, basically, how can we calculate the swapping? At first, we have to understand what is the original order here. The original order is 7, 6, 8, and 5. Now, let's make a vector of pair. The index of 7 is 0. The index of 6 will be 1. The index of 8 will be 2. And the index of 5 will be 3. After that, let's sort it. So if we sort it, it will become 5, 3, 6, 1, 8, 2, and sorry, it is not be 8, 2, it will be 7, 0. After it will be 8, 2. Now we have to compare the element into this sorted version with the original version. Now here, at first, we have seen that the value 7 is not equal to the value 5. So what is the respective position here of this 5? It will be 3. So we have to swap these two elements, which is the index number 3. So it will become 826170 and 53. Now again, as we change the first index, so we have to again look after it. So here, what is the element here? It is 8, which is not again equal to the 7. So we have to swap the element with the index number 2 with this. That means these two. So here, if we swap it, it will become 706182 and 53. But wait, did you find any pattern? Surprisingly, these two is exactly same. That means here we are basically doing the reverse thing. We are basically generating the original list from the sorted one. And by doing so, we will calculate the number of swap we needed. So here we have seen that we need 2 swaps. Similarly, we can perform this algorithm for each of the level, and we will calculate the total number of swap we need to sort each level. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named minimum operations, which has a 3-node root. Now we are taking a queue and storing the queue into the root. Initially, the answer is 0. Now, this is the BFS code. While the queue is not empty, we are calculating the size of the queue and declaring a temporary variable. Now, for each of the element in the size, we are storing the front element of the queue into a variable, then removing it and storing its value into a temporary variable. Now, if the current node has left children, we are inserting the left children. Similarly, we are inserting the right children if it has. Now, the answer will be equal to answer plus minimum swaps needed with this level temp. So here into minimum swap function, we are declaring a variable count initialized with 0, and we are declaring a pair of vectors. Now, for each of the element in the ARR, we are making a pair with its corresponding index. After that, we sorted it. Now here, we have to loop through the element. If the first element of the vector of I is not equal to arrow of I, we have to swap vector of I second and vector of I. And we have to decrement the I, because as we have changed the current element, the current element should be inspected once again. After that, we have to increment the counter. Finally, we have to return the counter. So here, finally, for each level, we have calculated the minimum swap and added to the answer. So we have to return the answer as well. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.